Hi, I'm Jeff Mucklin, and this is Science at Home, brought to you by the Nurture Nature Center. How do we keep our environments cool when it's hot? What is the science of cool? Let's look at a few ways that we can turn down the heat. This is a cooling towel, and it cools off your body through evaporation. When we sweat, water evaporates from our skin. When water evaporates, it goes from a liquid to a gas. And this is a phase change, and it absorbs a lot of energy. As water absorbs heat energy from your body, you become cooler. The heat is carried away by the now gaseous water vapor. Water can cool us down even without evaporating. Water is much denser than air, so a warm object submerged in cool water can cool down very, very quickly. This is why I recommended taking a cold shower or going for a swim on a hot day. Water works so well that objects like radiators can remove excess heat from something like an engine, which would get very hot and actually destroy itself without a radiator. And the people in the pool over there, I'm sure, very much enjoying the cooling effects of taking a swim. The Nurture Nature Center is located inside a very old building. It first opened its doors to the public in 1915. When it first opened, it was host to a movie theater called the Strand, and this was a silent movie theater. It was actually here in the room behind me. The screen would have been on that far wall there. Now, many early movie theaters would entice more people to come into the building by providing air conditioning. And for many people, this might have been their first experience with air conditioning. This particular theater was no exception, but it probably didn't have a large compressor like a modern air conditioning system. It probably used gigantic blocks of ice. The ice harvesting companies would store ice in large buildings, and then they'd sell it to customers all through the summer. If you have a large enough pile of ice, it will last all through the summer. The ice blocks were dropped into large pits just outside of the building, and fans would draw in air from the outside and blow it over the ice and then into this room. When ice melts, when it goes from a solid to a liquid, it undergoes a physical change that allows it to absorb heat from its surroundings. But we can make our surroundings colder through chemical changes. Now, most chemical changes involve the release of heat, and these are exothermic chemical reactions. They make their surroundings warmer. But some chemical reactions are endothermic, meaning they absorb heat and they make their surroundings colder. And I have an example of an endothermic reaction right here. This is a vial of ammonia nitrate crystals. It's a kind of salt. And I have here some water. And if we pour the water in with the ammonia nitrate will dissolve and it will start to absorb heat from its surroundings. Now, right now, the water that we're going to pour in is around 21 degrees, so it's just under that's 21 degrees Celsius, so it's just under 70 degrees Fahrenheit. And the ammonia nitrate is 76 degrees. Let's see what happens when I pour the water in with the ammonia nitrate. All right, so I'll just give this a little stir. So what's happening here is the crystals, the ammonia nitrate crystals are dissolving. But as they do so, they're absorbing heat and they're making their surroundings much colder. If you've ever used instant cold packs, that's exactly what is inside those instant cold packs. There's some ammonia nitrate crystals and a bladder of water, and if you pop the bladder of water, it mixes with the ammonia nitrate crystals, and you get this cold. A Peltler cooler is a somewhat unusual way to cool off our surroundings. They're not used very often because they're not very efficient, but they're very, very small and they're very reliable. They're mostly used to cool off computer parts, but it just looks like a little tile, just a little flat piece of tile. But if you apply a voltage to this tile, one side of it becomes hot. And if you remove the heat, like chill it with water or just blow air over it, prevent the hot side from getting too hot, then the other side can actually become very cold. So to show you this one in operation, I'm going to put, instead of using my thermometer, I'm going to use this piece of thermochromatic paper, which changes color with temperature, and I'm going to put it on top of this Peltler cooler. Watch what happens when I put it on top and apply a voltage. All right, here's our Peltler. Here's our thermochromatic paper on top of it. And I'm going to plug in the Peltler and watch what happens when I do. And I've turned it on, and look at that. A little square of a very cold surface is formed right where that tile is. Now, interestingly, this process can be reversed. So if we take our Peltler and we apply a voltage to it, one side gets hot, the other side gets cold. But if we turn off our Peltler and connect a multimeter to it, which measures electricity, we can actually make this produce electricity by making one side hot and keeping the other side cold. So right now, it's making a small amount of electricity, but watch what happens when I put my hand on the tile. Look at that. It's making electricity from the heat of my hand. So how do we keep our homes and businesses cool when it's hot? We use the refrigeration cycle, which is another reversible process. Let me show you what I mean. So I have here a steel ball that's completely sealed, and it's full of air, and it's connected to an air pressure gauge. And if we change the temperature of this ball, we change the temperature of the air inside, and that will cause the air to expand and contract, and that will change the pressure. So watch, if I put the ball in this bath of ice water, the dial, which was at 15 psi, begins to fall. That's because the air inside this ball is getting colder, it's becoming more dense, and so the pressure inside the ball is dropping, and it's a little sticky, but it's now about 14.5 psi. Let me get it right next to the camera so you can see it dropped. So I'm going to take this same ball and I'm going to put it in the hot water. So now the air inside is expanding. It's got nowhere to go, so as it expands, the pressure is rising, and it's now over 16 psi. This is a manual compressor pump, and I've been compressing the air in this pump, and it goes through this tube and into this cylinder. And where the air is being pumped, the compressor gets very hot. It's 111 degrees because I've been compressing the air here. But the air cools off as it goes back into the cylinder, and we can release that pressure from the cylinder, and the air inside the cylinder and the cylinder itself should cool off in the process. So I've waited a couple minutes for the bottle to cool back down to room temperature. I'm going to use my thermometer, and I also have that thermochromatic paper on the cylinder so we can see if its temperature drops as we release the pressure. It cooled down to 48 degrees. So we just reduced the temperature, and you can see the thermochromatic paper got much colder because the cylinder is colder now, because as we released the pressure, the air expanded and it absorbed heat, and it got colder, and it's made its surroundings colder. And fundamentally, this is the same way that an air conditioner works. I have here some liquid nitrogen, which liquefies at minus 320 degrees Fahrenheit. You may remember earlier in the video when we saw that cold temperatures reduce air pressure. Well, these balloons have some air pressure. I wonder what will happen to them if we submerge them in this vat of liquid nitrogen. When the balloons are submerged in the liquid nitrogen, the air gets very, very cold very quickly, and that makes the air become more dense, and the balloons deflate. If we take the balloons out of the liquid nitrogen, they start heating back up again, and as they heat up, the air expands back to its original volume as they return to their original temperature, and they reinflate. When the liquid nitrogen heats up, it turns back into a gas, and if you expose it to heat and moisture, it will produce a lot of fog as it does so. So here I'm going to take some crunch berries, some cereal, and I'm just going to soak them in liquid nitrogen. And now I'm going to expose them to a warm, moist environment, my mouth. For this week's at-home activity, I once again encourage you to sign up at IC Change. There will be a link in the description, and record your observations of extreme heat for the city of Easton. That will be very helpful. And I hope you continue to watch these videos. Ta-ta for now.